Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Yasin. So today I would like to present our vision and system projects with lecturer Prof. Madya Dr. Rosli bin Omar. So this is our team member, and the question, the task that we are given is we have given a checkboard with 25 dimension of square. Use two cameras to capture provide image. By using the task given, we need to get a rectified stereo image, reconstruct a 3D scene, and compute the 3D location corresponding to match pair of image point. So I would like to present about the introduction of our report. So as we have given the task about the assignment, so we need to the calibrating camera is a crucial for creating accurate 3D models and understanding the space around us. This process use a known pattern like that be given 4 times 6 checkboard with 25 millimeter squares to help the camera understand the distance and the angles. In this task, we used the two cameras to capture image of the checkboard and then use MATLAB software. The stereo camera calibrator apps. First, we rectify the stereo image, aligning them so that the matching points in both images line up horizontally. This makes it easier to find matching point between the two images. Next, we reconstruct 3D scenes by using the matches point to determine their exact 3D location. This method helps us accurately map out the position of object in space, which is essential for application reading precise 3D measurement and depth perception. And we have give the relate some the relevant theory here. So that's it for introduction parts. Thank you.
Hi, Assalamualaikum. My name is Mohamad Azizi bin Razi. My metric number is CE210117. Okay, for today I will present about the methodology for our assignment 2, which is conducted by Dr. Rosli bin Omar. So, the objective of this project is to calibrate a stereo camera setup using image of an 8 times 6 checkerboard. So, from the question, we know that we are using the same checkerboard from the assignment 1. So, now let's take a look at the equipment and setup. So for the equipment and setup, we only use three things. So for the first thing is we need to have a checkerboard, we need to have a camera, and finally we need to have a software. And the software that we use is a MATLAB with the stereo camera calibrator apps. So now let's go to the procedure. So for the first procedure is the image capture. So we need to set up and capture where we have to take multiple pair of image of the checkerboard from different position and orientation. Next, we have to preparing the image. So we need to store the capture image pair in a designated directory, organize the image so that each pair of left and right image can be easily matched. After that, we need to import the image into the MATLAB. So we just need to add the image pair, click on the add image pair button and navigate to the directory containing your image. Select all pair of image to import them into the apps. After that, we need to do the checkerboard configuration where we have to enter 25 for the square size of the checkerboard, and for the checkerboard dimension we need to enter 8 for the number of square along the width and 6 for the number along the height. And after that, we go to the corner detection. So for the corner detection, there are two type of way where it can be automatic and also the manual adjustment. So the apps will attempt to automatically detect the checkerboard corner in each image pair, and also we can use the manual adjustment if the automatic detection is inaccurate. And finally, we can calibrate. So once all the image pair are added and corner are detected, click on the calibrate button. The apps will process the image to compute the intrinsic and extrinsic parameter. So that's all from me. Now I will pass it to my next team member to discuss about the result and discussion. So thank you.
Hi, my name is Mohamad Irfan. So today I'm gonna present about my results for the vision system for assignment 2. So for this assignment we need to use the stereo camera calibrator, this one from the MATLAB. So just click on this and then it will appear another window. Okay, so now we open the stereo calibrator. Then I will open my recent session. So for the session I already done for this assignment. So this one calibration session. So I'm gonna open up. Okay, so it's just loading. Okay, so this one I already calibrate the checkerboard. Okay, there are many angles we put for the stereo camera. So there are 12 samples we have done. So there are various angle from upper, downward, and also left and right, and also other angle. So this one we just collect the checkerboard. We collect from this. This one is for the left side for the camera, and then this one is right side for the camera. So both we upload it to the MATLAB calibrator. So this is the result we got. So after we get the result, then we can generate the MATLAB script. So this one, this MATLAB script from the calibrator app. So it will show the command that we can run. So we try to run. So this one just put this on the desktop. Okay, then just wait for the result after run the code. Okay, so we appear this one. There are two figure, which is the mirror projection error per image. So we get the 0.38 pixel for the mean error. So it can be high, not too high. And then this is for you too, for the 3D. You can see the many angle we set up for the checkerboard pattern. Then for the result you can see here there are camera 1 is 36, then S36. So this is the data we got from the calibrator. So this after we run the coding, rotation vector. So all the value will show right here. So this there are camera 1 and camera 2. Okay, so that's all for my presentation for the result. Thank you.
Okay, Assalamualaikum and hi. My name is Mohamad Hamsyari Hamizan bin Muhammad Zaidi, and my matrix number CE210123. And now I will continue the presentation at part discussion. Okay, so after we run the coding at the MATLAB, then at the command window will appear standard errors of estimated stereo camera parameters, and it will show the camera 1 is 36, which have focal length in pixel, principal points in pixel, and the radial distortion. It also will show the rotation vector as we can see here. So next, it will also appear the translation vector in millimeters. Then camera 2 in 36 also have focal length in pixel, principal point in pixel, and the radial distortion. Last but not least, the position and orientation of camera 2 relative to the camera 1 also will appear, and it have the rotation of the camera 2 and the translation of the camera 2 in millimeters. Okay, next for the image statistic, our project is used the total image is 24 because of we save the left 12 image and right 12 image to build this assignment successful. So you can see there are many factors that the image will accept it and they reject. So I can say that if the image is accepted, maybe the ideally matching is total significant good image quality and successful pattern detection. So if reject, maybe it have such a blurriness, not good in lighting, or incomplete detection, or the repeated image of the same angle. Okay, for the reprojection error, reprojection, overall I can say that the chart indicates a successful camera calibration with no reprojection error. The reprojection error actually refers to the differences between the actual location of the point in the capture image and the location where the calibration model predict those points should be. Lower areas signify lower areas signify better alignment between the model and the real world, and uh, therefore a more accurate calibration we will get. So about the camera parameter or the camera movement, actually the concept during the calibration, the camera actually captures multiple image of the checkerboard from various angle and distances, as I mentioned before. This movement provides diverse data point for the software to analyze. Much important is by capturing the pattern from different viewpoint, the software can understand how the camera can translate and rotate in space relative to the object. This information is actually crucial for accurately reconstructing the object of the 3D geometry. Okay, I think that's all for me. Thank you.
Hello, my name is Ahmad Nazrein Hakkeem bin Aziz. So I'm going to end this presentation by explain about the conclusion. Okay, in conclusion, calibrating a stereo camera setup using a 8x6 checkerboard pattern with 25mm squares coupled with matched stereo camera calibrated apps enable precise alignment and calibration of stereo image. The process involves a rectifying image to ensure corresponding points align accurately between left and right image. This rectification simplifies the identification of matching points, facilitating the reconstruction of detailed 3D scene through triangulation. The calibrate setup allow for precise computation of object position in 3D space, providing a comprehensive spatial understanding essential for application demanding accurate depth perception and spatial analysis. This calibration process forms a crucial foundation for advanced stereo vision application across various fields, ensuring reliable and detailed 3D scene in reconstruction. Okay, that's all from me and our group. Thank you so much.